This is an example of the relation between spanning set for a vector space and linearly independence. Well, let's look at a set of vectors v1, v2 to vn. And this set of vectors here is a spanning set for the vector space v. Right. And let v, another vector v, be another vector in v in the same vector space. And you want to show that v, v1, the set v, v1 to vn are linearly dependent. Well, let's look at all the conditions that we have, all that we know, right? So we know that v1, v2 to vn, a set of these vectors here is a spanning set for v, right? Vector space v. What does it mean? That means there exists a set of scalar alpha 1, alpha 2 to alpha n such that if we pick a vector in v, right? Let's say this vector is such that v, because v is in the vector space v, then we can just use vector v. V equals to alpha 1 v1 plus alpha 2 v2 plus alpha n vn. Okay, again, vector v here is the vectors that we talk about up here, is a vector in vector space v. So if v1, v2 to vn is a spanning set for v, then there will exist a set of scalar a1, a2 to alpha 1, alpha 2 to alpha n such that v is equals to alpha 1 v1 plus alpha 2 v2 plus alpha n vn, because v here is a vector in vector space v, and this is the definition of the spanning set for vector space. In another word, v is a linear combinations of v1, v2 to vn. And now we want to show that v, v1, vn are linearly dependent. V, v1, vn are linearly dependent. Okay, so in order to show this, we need to consider a, so to do this, to show this, we want to consider the equation, let's say beta v1, beta v, right? We have to start with beta is a scalar, beta v plus beta 1 v1 plus beta 2 v2 plus beta n vn equal to 0. We consider these equations, and to show this, consider the following equations and show that beta 1, beta n are not all 0. So if you can show that there exists a set of scalars that not all 0, that will satisfy this equation, that means v, v1 to vn are linearly dependent. Because remember, if this set of vectors are linearly independent, then all the scalars has to be 0. Okay. Well, let's see what we have here. So we have this as the conditions information that we know. Okay, so here is the solution, solutions. Since we know that v equals to alpha 1 v1 plus alpha 2 v2 plus alpha n vn, then we can move v to the other side. So then I have 0 equals to, or let's move this. I move everything to one side, right? So I have V1 V minus alpha 1 V1 minus alpha 2 V2 minus alpha n Vn, right, equals to 0. All right, so now I just found that means that implies the set of scalar one, negative alpha 1, negative alpha 2, negative alpha n the set of scalar, this scalar here, I will show you one here, alpha 2, 1, alpha 2, and alpha n. The set of scalars satisfy the equations that's not R0. And satisfy the equation number 1 thus by the definitions the set of scalar v, v1, vn are linearly dependent. Okay. Because we already show that if you consider these equations, and if there's a set of scalar that not R0 that satisfy this equation, then V1, V2, V1 to Vn are linearly dependent. And this is what we show here. So we use the condition that we have from the fact that V1, V2 to Vn is a spanning set for V, and the fact that V here is a vector in the vector space V to come up with this equation here, right? And from these equations, I move everything to one side, set the other side to be equal to 0. So this equation here and these equations are the equation that we want to look at. Okay, so we have V1, V2 to Vn, we have V here, and now I found that the set of scalars, which is 1, V negative alpha 1, negative alpha 2, negative alpha n, is a set of scalars that are not all zeros, because at least one of the entry is not 0, which is 1, right? They're not all zeros, and they also satisfy the equation number 1 here. So by the definitions, V1, V1 to Vn are linearly dependent. Now this is how you use the definitions of linearly independence of a set of vectors. Have you use a definition of spanning set for a vector space in order to show that if you have a set of vectors is a spanning set of a vector space, and then V is another vector in the same vector space, then the set of vectors V, V1 to Vn are dependent on each other.